Hey guys, this is Evan. I'm here to show off my script I wrote that basically emulates a calculator's ability to turn on, turn off, and turn the lights on and turn the lights off. And I did it using a state machine approach. So this is a design pattern that is used in object-oriented programming where you have a class that is the machine, which basically holds the state. That's what we have up here, class machine. And then its state is dependent on these other classes, which are basically objects that tell the state how to behave. So let's do a walkthrough here and see if we can get an idea of what's going on. I like to start at the dunder name equal to dunder main. This is where the script actually begins. So this is basically a high level view of what the code is doing. At the start, we instantiate an object of the machine. So this is the object that's going to be running the methods that describe the behavior. So when the machine, which is the calculator, when the calculator is turned on, we're going to print the this property of the machine, which is its brightness, to see what its brightness is. Then we're going to turn the lights off. So the calculator is still going to be on, but the lights are going to be turned off. Then we're going to check the brightness. Then we're going to turn the lights back on. Then we're also going to set the brightness. I have a method in here that allows us to do that. Print the brightness again. Then we turn the calculator off, check the brightness, set the brightness again to 8, see, basically get an idea if we can capture the behavior as the calculator is either on or off, and if the light is on or off on it. And the light being on or off is dependent on the calculator being on and off. So that's kind of the idea of the state machines, that you can capture these stateful behaviors. You don't have to depend on if statements as much. So without further ado, let's get into it. Here we have the machine class. Its methods are the calc on, calc off, set brightness, light on, and light off. And what these methods do is they're going to load an object of one of these classes that represent the states into the state variable. So I'm showing it up here. It's a property. It's a class of the property. Oh, sorry. Ugh. It's a property of the class, which, if anyone watching this is savvy, you'll know that this is actually something that is maintained through all the objects that are machine. But since we only have one machine, it's not really going to matter. And since we're just accessing the object, I just kind of put this up here really so that way. I don't know if you guys know my style, but basically I put this up here just to remind myself of what are properties of the class. I really shouldn't be doing this, so this is a bad code form to put properties up here under the class. It's really only useful in certain circumstances. Alright, so going to the instantiation, when I first create this machine object, the state is set to calculator off and the light state is set to light off. So as you can see here, we are setting the state equal to an instance of this. Here, the light state, we're setting a light state to an instance of this. So calc off class, that is this class, it is having an instance of it created. And what it's doing is when it calls it, it has a function in it, so you can actually call back to the state, and this basically switches it to on. So when we run the calc on method, what we are actually doing is we are executing the calc on method within this this object's method. So when we execute this calc on, the method of this object calc off class is executed, and what happens is it switches it says, okay, take the machine and set its state to calc on. As you can see, this machine is being set up here. It takes itself. So this is really important thing that's going on here. The method of this object that was calc off is taking an argument that is the self of the machine. So it's taking the machine. That's how this method knows what's going, or this class knows what's going on. That's how these classes are able to kind of talk to each other. So then we set the brightness because the calculator's on, and the light state also gets set. So as you can see, what's going on is we have two states that we're kind of setting here. There's not just one state going on. There's actually two that I'm demonstrating with this example, and I think that's useful in some situations when you want to make things a bit more complicated. It allows you to see how state machines can kind of grow to be these big complex systems that cleanly maintain the state uh, depending on where you are in the flow or process of your calculation or computation. So then here we have it print out the state. That's basically the viewer component of this code piece. And then I also have it printing over here what the machine's brightness is. So I'm kind of displaying it in two ways. One is I'm just printing it straight from the method of the calc_off class, and then the other way is I'm just doing it straight from the machine object. So now I run the light off, and the machine.lightOff method. What this does is it checks if there's an instance. It basically it checks if the calculator is on or off. Because what will happen is if you try and if you try and do light on or light off while the calculator's off, it's gonna say, so, it's gonna give a response depending on its state. So for example here, if there's an instance of the calculator not being turned on and you're trying to turn the light on, then it's going to print calculator's off, can't turn on the light. So and then in the other instance it'll just execute the method. So this is how you can basically catch parts in your system where you're trying to go from one state to another and it won't let you. So you can do a check, you can do an if is instance check on the state. So this is a special thing in Python. This is basically checking this object and seeing if it's of type calc_off class, which is this class down here. And that's useful in state machines, obviously, because it lets you check what kind of object you have, or what kind of class you have that's occupying the state. And then we have some other methods here that basically work similarly as I was mentioning, which let you flip through the state. So here's calc_on, just works the way I said. Calc_off works the way I said. And then set brightness, it's dependent on calculator being on. So all the logic is existing in the machine. That's another thing to mention. Basically, all the logic when it comes to turning lights on and off, and then I guess it's hard to say this, but the other logic then is when you have when you're flipping through states. So it looks like there's two ways to really do this. You can either put your logic in the machine. I think that's what I was kind of demonstrating here with this, because this is kind of messy how there's logic existing in both places. This is demonstrating how you can have your checker logic either in your machine, or you can also have it in the individual classes, depending on what kind of degree of control you want when it comes to flipping through states. So if you could think of this as like a graph and you're moving through each state, you could always go from one state to another in kind of a nonlinear fashion, and this kind of lets you capture all those combinations that can occur. So yeah, in a nutshell, that's my state machine that I have here, which is basically a calculator where you can either turn it on or off, and its light will turn on or off, or its brightness will be set depending on whether the calculator is actually turned on or off. it's kind of verbose. Like if you stand back and think about it, this is quite a bit of code. But I think when you compare it to something that you wrote using a lot of if statements, this is definitely the more readable and more decoupled approach, because you can isolate your states into classes, which allow you to control the behavior and give you kind of a finer grain of control to allow you to put more if statements. Whereas if you kind of try to do this all in one if statement or set a series of if statements, you're gonna end up with something that's nested by like 4 or 5 if statements deep, and that can just be a nightmare of maintenance when it comes to um, trying to maintain that code and looking back and trying to understand what's going on. I think this is a bit more of an easier way to understand how the system behaves. Once you kind of get past the complexity of the object-oriented approach, and you just look at what the classes are doing, you can get a really good understanding, easy understanding of what the behavior of the system is going to be. So there you have it, guys. That's my state machine. So running it on here for you, basically, it's just outputting um, statements based on what I have in the class methods, as well as what I'm showing here is being printed. So here when I run it, calculator's turning on, so calculator's switching to on. Print the machine brightness, it's at 10. Then you turn the light off and then print the brightness, and you see it's at 0. Then we set the brightness to 8, we get 8 here as the output for the brightness. Then we turn the calculator off, and then it prints, okay, calculator switching off. And then we check the brightness again, it's 0 now, because when the calculator switches off, it knows to set the brightness to off. So if we come here and we go to calc off, or calc on, then we go to calc off, the machine brightness gets set to 0. So. And then finally we try and set the brightness when the calculator's off, and we get a message that says calculator's off, can't turn on light. So that's basically demonstrating the states and the statefulness of this system. I hope you guys enjoyed this video. Kind of a off-the-cuff explanation. I wish I could have polished it off a little bit better, but it's such a small script. I think it's something that anybody could really pick up with 5 or 10 minutes of studying it. So I'll have the GitHub link posted below for you guys to check this code out. Anyways, have a good one.